In this presentation, we will demonstrate how the PDM analysis product SCORG and Simerics-PD from Simerics Inc. have been integrated to provide a complete solution to modify, analyze, and improve screw compressor designs. Here is the twin screw compressor that was used as our example for this presentation. On the left is an image of the compressor on a test rig used by the City University London for physical testing. On the right is an exploded view of the CAD showing the different components. This is the typical workflow. The initial geometry is imported into SCORG for modification and pre-processing, then directly linked to Simerics-PD for simulation and analysis. This information is then used to further modify the design, and the cycle repeats until the performance criteria are met, resulting in a fully optimized product. Within SCORG, the imported rotors can be manipulated, scaled, and modified. From the modified contours, the complex three-dimensional rotor mesh is then generated. Building the rotating 3D mesh is one of the biggest simulation challenges for this type of machine. After the mesh has been created, the working conditions are specified and SCORG's pre-processing scripts are used to create the necessary files for the direct link to start Simerics-PD and run your simulation. Within a couple of hours, Simerics-PD provides a converged solution with all of the relevant engineering output that you would expect from a hardware test. Point data, integrated quantities, flow visualizations, and surface data including pressures, velocities, temperatures, and integrated quantities such as loads, torques, and power can be used to produce performance curves, images, and animations that provide valuable insight that is not usually available with physical testing. These are some of the actual simulation results compared with experimental data collected by City University. Simerics-PD was used like a virtual test stand to predict specific and indicated power, volumetric flow rate, and efficiency as they relate to rotor speed, as was done in the physical experiment. This chart shows how Simerics-PD was able to capture the pressure magnitude throughout the rotational cycle of the male rotor. Specifically of interest were the results at the 230-degree position where the discharge was fully open. This is an animation created with Simerics-PD of the pressure distribution on the surfaces of the rotor at 8,000 RPM. Here, the surface temperature is displayed, indicating a range of 250 to 500 Kelvin. In this animation, particles were introduced to visualize any swirling patterns that would indicate areas of inefficiency. Notice the high level of vorticity at the suction inlet. In summary, SCORG and Simerics-PD provide a fully integrated software solution for the analysis and simulation of screw compressors. The design engineer can use SCORG to manipulate, scale, and modify their rotors and create a complex mesh and the pre-processing files that are necessary to directly link to Simerics-PD. Simerics-PD simulates the actual compressor system, including the porting. Its results can then be used to analyze flows and losses and predict performance, as well as provide valuable insight for design modifications. For more information or a demonstration of the software, please contact PDM Analysis or Simerics via the information below.